Until very recently, it wasn't possible for someone to pick up a microcontroller and have it controlling his or her world within minutes. With Arduino, the possibilities are endless, and it will become our new favorite tool as we explore the world of electronics, programming, human-computer interaction, art, control systems, and more. Throughout the course of this video series, we'll use the Arduino to do everything from detecting motion to creating wireless systems to communicating over the internet. Whether you are completely new to any kind of engineering or are a seasoned veteran looking to get started with embedded systems design, Arduino is a great place to start. All Arduino boards have few key capabilities and functions. Let's take a moment to examine the Arduino Uno. It will be our base configuration, and these are some key components that we'll be concerned with. Number 1, the Atmel microcontroller. Number 2, the USB programming interfaces. Number 3, the voltage regulator and power connections. Number 4, breakout I/O pins. Number 5, debug, power and RX-TX LEDs. Number 6, reset button. And number 7, in-circuit serial programmer or the ICSP connector. Now let's look at the Arduino hardware. First off, we have the Atmel microcontroller. At the heart of every Arduino is an Atmel microcontroller. Arduino Uno uses an Atmega 328P, and this microcontroller is responsible for holding all of our compiled code and executing the commands we specify. A 16 MHz ceramic resonator is wired to the Atmega's clock, which serves as the reference by which all program commands execute. The general purpose IOs and ADCs. The Arduino programming language gives us access to microcontroller peripherals. All of this useful functionality is broken out from the tiny pins on the microcontroller to accessible female headers on the Arduino that we can plug wires and shields onto. Arduino Uno has pins from 0 to 13 which can serve as digital inputs or outputs. Additionally, the pins with a tilde mark can act as PWM outputs. Many of these pins are also multiplexed to serve additional functions which we'll explore later. These special functions include various communication interfaces, serial interfaces, and external interrupts. The reset button and LED. We can use the reset button to restart the execution of our program. Most Arduino boards come with a debug LED already connected to the pin 13. This enables us to run our first program that is blinking an LED without connecting any additional circuitry. Programming. Perhaps the most important characteristic of an Arduino is that we can program it easily via a USB cable. In the case of the Arduino Uno and Mega 2560, a secondary microcontroller, an Atmega 16U2, serves as an interface between a USB cable and the serial pins on the main microcontroller. However, in some Arduino boards, an FTDI USB to serial chip is used as an interface between the Atmega's serial USART port and a USB connection. If we weren't to program directly from the USB port, the onboard ICSP header can be used. Power supplies. For the majority of our projects, we'll simply use the 5V power that is provided by the USB cable. However, when we are ready to untether our project from a computer, we have other power options. The Arduino can accept between 7 to 12 volts via the DC barrel jack connector or directly into the VN pin on the Arduino. It has built-in 5V and 3.3V regulators, where 5V is used for all the logic on the board. In other words, when we toggle a digital I/O pin, we are toggling it between 5 and 0 volts, whereas the 3.3V is broken into a pin to accommodate 3.3V shields and external circuitry alike. Now that we are done with the basic introduction and a hardware overview of Arduino, let's explore the different kinds of Arduino boards. Arduino comes in all shapes and sizes. We cannot possibly cover all of them. However, we will explore some of the features in the official Arduino boards. Uno. Uno was the flagship Arduino, and it uses a 16U2 USB to serial converter chip and an Atmega 328P as the main microcontroller, which has 14 GPIOs, 6 PWM channels and 6 analog inputs. Mega 2560. Arduino Mega 2560 is an Arduino Uno on steroids, which employs an Atmega 2560 as the main microcontroller, which has 54 GPIOs, 14 PWM channels and 16 analog inputs. Nano. Arduino Nano is a small, complete and breadboard friendly, and it offers the same connectivity and specs of the Uno board, just in a smaller form factor. Lilypad Arduino. Lilypad Arduino is designed for e-textiles and wearable projects. It can be sewn to fabric with sensors and actuators with conductive thread. It is based on the Atmega 168V, the low power version of the 168T. 101. Arduino 101 is the new flagship Arduino which replaces the Arduino Uno. It is powered by the Intel Curie module designed to integrate the core's low power consumption and high performance with the same ease of use. The 101 adds Bluetooth low energy capabilities and has an onboard 6-axis accelerometer, providing exciting opportunities for building creative projects in a connected world. Here is a summary of our comparison. So that wraps up this video, guys. In the next video we'll learn how to program an Arduino, so stay tuned for that. Like this video if you liked it, dislike it if you disliked it, subscribe to my channel, and I'll see you in the next one.